Hello, everybody. My name is Alessio Luschi. I am a research fellow at the Department of Information Engineering at the University of Florence in Italy. I'm also a PhD student at the same department. And this work is about sentiment analysis for health technology assessment in hospitals. The team is made by myself, by Giulia Polisena, which is a member of the HTA division at the IFMBB. Then we have Ernesto Iadanza, which is the chief of the HTA division at the IFMB, and is also the coordinator of this project. We also have Lorenzo Masci, which is biomedical engineering, and his thesis is based upon this topic. In recent years, we have that real-world data has been crucial in technology assessment, and they generate reliable real-world evidence, which is very useful in terms of HTA. The main challenge about real-world data is the higher degree of heterogeneity and the fact that they are unstructured. They are reports. They comes from papers, so it's text that is it comes in forms of unstructured data. Maintenance is also a crucial subject for medical equipment lifecycle management. And evidence-based maintenance consists of the continuous performance monitoring of equipment. Work orders and maintenance reports are usually stored inside computerized maintenance management system, or CMMS, which can also be seen as real-world data sources. We also in this study, we also take a knowledge of the natural language processing techniques, which concern with the interaction between computers and human language, and are all the techniques that can transfer information from text from corpora to data that can be read, can be seen by computers. So we have also sentiment analysis, which is a methodology to solve NLP problems by analyzing opinions, evaluation, and sentiment of people in relation to any kind of topics. We designed this framework, which is part of a wider framework that is shown here in this slide. The main framework that this work is a subject of relies on using deep learning and machine learning approaches together with NLP techniques for data mining of real-world data from papers and from reports or any other corpora unstructured data. Then we try to extract this data by using different techniques and aggregate them in order to extract real-world evidence that can be used for different goals, such as evidence-based maintenance or HTA in general. We also designed 10 classes to classify the maintenance reports, to classify the faults that are analyzed in the maintenance reports. These classes are shown in this table. These classes will be also used to label and to train the machine learning algorithms that will be used to classify the maintenance reports in order to extract real-world evidence. We also designed these 20 key performance indicators both they are technological ones, organizational, or financial. And some of these indicators can be evaluated automatically from the classes that are shown before. So we try to design a system that can respond, that can actually respond to EBM techniques and to EBM needs by automatically evaluating these key performance indicators from the outcomes of the framework. The framework that take care of the extracting real-world data and real-world evidence from the CMS is the one that is shown here in this figure. We have the both scheduled maintenance and corrective maintenance reports that come from the CMMS data store. We apply some pre-processing that are very common in natural language processing, like tokenization, stop words, or lower casing. Then we extract features by using the TF-IDF algorithm, which is term frequency inverse document frequency, and it gives a weight to every single word inside the corpus of the report, depending of the frequency that the word itself appears inside the document. Then we apply the smooth technique for overcome the unbalancing problem that the original data set may have. And then we apply a support vector machine classification model in order to extract the classification according to the 10 classes that we have seen before. So we use the 10 classes both for training and then for validating the machine learning techniques. So at the end, the outcome of this framework, which I repeat is part of a more wider framework that I have shown you before, the outcome is the classification, the automatically classification of the maintenance report inside these 10 classes of false. Then we can automatically evaluate some of the key performance indicators that I have shown you before directly from these classes, which are, as I repeat, the outcomes of the framework itself. And so this is everything for this presentation, and I'm waiting to answer to your question at the live Congress.